All right, so welcome back, and this is now learning goal 48. So we're going to be taking a look, and this is just an extension of 47, where we started looking at area of 3D prisms and a little bit of composite shapes. We're going to look a little bit more intently at composite shapes and how they are calculated, how the surface area of a 3D composite object is calculated. Now, let's just remember that a composite shape is one that is made up of two or more regular shapes. Okay, so two or more regular shapes would make up a composite shape. A composite object, okay, is a 3D object. And now again, shape will be 2D and object I'm going to say is 3D. So a 3D object, which is a combination of two or more regular objects, so regular 3D objects. So think of it as like regular prisms, okay? We're normally gonna think of them as prisms. If you continue on, if you take in grade 10, you'll be looking at different 3D shapes that don't include prisms, but for grade 9, we're just gonna take a look at prisms. Now the surface area of a composite object, now remember, surface area represents 3D, area represents 2D, that's how I'm using it. So the surface area of a composite object can be found using the area of the regular objects, okay, and subtracting the parts of the regular object which are covered by the joint. Okay, so we can think of two shapes or two objects being put together and there being a joint in between. We want to subtract that joint piece. Okay, we want to subtract that joint piece because that's unseen. So it's not actual surface area of our regular shape. And it's not actual surface area of our regular shape. Now, how do we find this? Well, I gave you this in Learning Goal 47. So if you've watched those, you've seen those notes, you'll see it's all pretty much exactly the same here. Okay, so how we do that is the first thing we do is we list or at least determine the regular shapes or the regular prisms which make up the composite object. Okay, so we list the regular prisms which make up the composite objects. Now in this case here, we're just going to put a quick little line through here. Let's do it in red. Okay, the two shapes that we have are maybe not completely clear, but should be mostly clear. We have a triangular prism here on top, and then we have a rectangular prism here below. Okay, so triangular prism on top, rectangular prism here below. Now, the next thing that we do is we find the surface area of each regular prism. Okay, so we're going to find the surface area of the top one and the surface area of the bottom one. Now, I'm not going to go through, or I'm going to try to go through this semi-quickly, and not take too much time, but we have this rectangular prism here on the bottom. Okay, and to find the area of that, okay, in total, we have an 8x4, a 3x4, and a 8x3, okay? So to find that, and we can kind of think of it in the case of, let's go with our surface area one. Let's call this the base here, okay? So a 3x4 is gonna be our base. So we're gonna do 2 times 3 times 4. Which may put centimeters in here. And then we're gonna add the perimeter of that base, and so it's 3 plus 4 plus 3 plus 4, so that is 14 centimeters. That's our perimeter times 8, which is our length. And this regular prism right here, let's slide out to grab a calculator. Okay, 2 times 3 times 4 plus 14 times 8 gives us 136 centimeters squared. Okay, so that's the rectangular prism, 136 centimeters squared. That's the entire thing. I haven't subtracted anything. I found the one that's underneath the joint. I will have to subtract that yet. Okay, the triangular prism, and let's do that in a different color here. Let's do a little more contrast. Let's do red. Triangular prism. And now, so now we need to do again the base. We're going to call this front the base. This is an 8 by 6. Okay, this is 6. This whole thing is 10. Okay, remember this one's 4 and this one's 6. So we'll just okay, 2 times. Let's just get out of it just for a second here. Okay, so we have, remember this one here is 6 centimeters, and this side here is 4 centimeters. And so the triangle is actually an 8 by 6. Okay, so triangle is actually an 8 by 6. So it's 2, and then we have base times height divided by 2. So this is going to be 6 centimeters times 8 centimeters divided by 2. Then we're going to add the perimeter. So it's going to be 8 plus 6 plus 10, which is 24 centimeters times 3 centimeters, which is the length. Again, this is the length here of this one. Okay, different length than our base. And when we solve that, it's going to be 120 centimeters squared. Okay, so that's our total there. And then what we also have, so that's finding the area of each of those. Now, once we have the area of each of those, we go back to number 3 here. We're going to subtract the areas of the overlap for each of the regular prisms. And I'm going to put this here kind of in brackets. These are our joints. Okay, these are our joints. We need to subtract the joints. Okay, now our joints is going to be this piece here. So this rectangle that we can kind of unsee, or we don't see. So it's 3 by 8. So we're going to do 3 centimeters times 8 centimeters equals 24 centimeters squared. And there is a joint. In that joint, there are 2 sides. We have to subtract 2 of them. Okay, so what we're going to be doing here is we're going to be taking the 2 of them, 24 centimeters squared, and we're going to multiply it by 2 because there is always 2 sides to a joint. And so this is 48 centimeters squared. So what we did is we found the area of the rectangular prism. That's what we did this first one here. We found the area of the triangular prism, or the surface area of the triangular prism. And then we found the area of that joint and multiplied it by 2 because there are 2 sides to every joint. Okay, there's always the one side and the other side, they join together. Okay, those 2 sides both have to be subtracted because we don't see them anymore. So then the last thing that we do is we add all the surface areas together to get the combined surface area of this composite shape. And so on the bottom here, the total area is equal to 136 centimeters squared, which is our rectangular prism, plus 120 centimeters squared, which is our triangular prism, and then we subtract the 48 centimeters squared, which is our that joint area. And so when we do that, we got 136 plus 120 minus 48 is 208 centimeters squared. And that gives us our total. Now, the alternate plan that we could do, okay, and I'm not going to go through this. I'm just going to let you kind of look into this and kind of think of it on your own here, is we can find the area of each side of the composite object. And once we have that, then as we've done in the past, we add all the sides together and we solve for it. So we can think of, we have this composite shape here, this rectangle and triangle. We have rectangle, rectangle, rectangle on bottom, rectangle on side, and then we have the common triangle and rectangle on the back side. We add that all together and that will give us the total. The other thing that we can think of is the fact that this kind of looks like a prism with a composite object front. Okay, it's a composite object front. So we could use this same formula that we used for a regular prism, find the area of this composite area, so the triangle or composite shape, the triangle and the rectangle, join them together. And this is what I'm kind of saying here on the bottom. And then we could take the perimeter of the outside and multiply by 3. Okay, And so we can think of it, and I'm going to put this out, it's going to look a little bit odd, or I should maybe say big. Okay, so remember that, let's do this one more time here. The surface area, area of a prism is equal to 2 times the base area plus the base perimeter times the length or width of our shape. And if we do that for this one that we see here, I'm going to simplify this a little bit here. I'm going to do SA for surface area is equal to 2 times the base area. Okay, now the base area is our rectangle, and I'm going to use this as the whole base area, this rectangle and the triangle. Okay, rectangle and triangle. So I've got an 8 by 4 on 4 centimeter plus the area of that triangle, which is going to be 6 by 8. All right, going up and down here a little bit. So that is 6 centimeters times 8 centimeters divided by 2. And so that is our base area. Now that's a lot of work here. We've got to combine that. But then all we do now is we're going to add our base perimeter, which is the distance around. Okay, so I've got 10, 8, 4, and 10. So that's 20, 28, 32. Plus 32 centimeters times the 3 centimeter length, which is this little right here. There's a 3 centimeter length. And when we multiply that all together, okay, so I'm going to 2 times, and then 8 times 4 plus 6 times 8 divided by 2 plus 32 times 3. And wouldn't you know it, and if you want to look at my calculator, on the corner there, 208 centimeters squared, which is in fact the exact same that we got using this first method. So that is another way that we use it if it is a prism. Okay, if it is a prism. Now I'd like you to work on question 1. It comes in many parts, so there's A, B, C, and D in there as well, and E. Okay, so we got up to E. So I'd like you to work on question 1. Find the area of the composite shapes. Check your answers in the answer key once you have finished.